In this video, I'll demonstrate how to add vectors for displacement and for velocity. There is an assumption that you'll be familiar with trig ratios and Pythagoras' theorem. So the first example, we're looking at displacement. So a person walks 2 kilometres north and 3 kilometres east to get from their house to the post office. So we're going to say that north is in this direction, and we're going to draw a diagram of the scenario. So we have our person walking 2 kilometres north and 3 kilometres east, and we want to know what their displacement is. So the magnitude or the size of their displacement is going to be this dotted blue line, and the direction of their displacement is going to be this angle here. So essentially what we've got is a right angle triangle, and we're trying to find the length of the hypotenuse and the size of the angle within the triangle. So in order to find the length of the hypotenuse or the magnitude of the displacement, we'll use Pythagoras' theorem, a squared plus b squared equals c squared being the hypotenuse and a squared and b squared being the other two sides. So 2 squared plus 3 squared will give us 13. We want the square root of 13. So the length of our hypotenuse is going to be 3.6 kilometres. Now we have got the magnitude, we want to find the direction of displacement, so that's where our trig ratios come in. So the trig ratios are sine, cos and tan, and we can use SOHCAHTOA. Now technically we've got the length of all of the sides of the triangle, but just to be sure, you never know if you've made a mistake in calculating the length of the hypotenuse somehow. So I would prefer to use the trig ratio that relies on the values that I was given in the question. So this is going to be my adjacent and my opposite, so I'm going to use tan. So I have tan of my unknown angle is equal to the opposite over the adjacent. So the angle will be equal to the inverse tan, and I'll substitute my values in, 3 over 2, which is going to give me an angle of 56 degrees. So what I can say is that this person was displaced by 3.6 kilometres at an angle of 56 degrees northeast of where they started. And the second example for this video, looking at velocity. So a boat sails 15 knots west and a current is running south at 3 knots. So west is going to be in this direction, and I'll draw a picture. My sailboat is travelling at a speed of 15 knots in a westerly direction, and the current is pushing it at a speed of 3 knots in a southerly direction. I'm going to move that. I'm going to move that over here. 3 knots. Cool. So the magnitude of the velocity, so the velocity of the boat in a southwest direction is going to be, again, the length of the hypotenuse, and the direction is going to be the size of this angle here. So I'm following exactly the same steps that I followed in the previous example. I'm going to use Pythagoras' theorem, a squared plus b squared equals c squared. So 3 squared plus 15 squared. So I'm going to end up with 15.3 knots is the length of the hypotenuse, or the speed of the boat. And again, I'm going to use the tan ratio because I've got the opposite and the adjacent sides given to me in the question. So the size of the angle is going to be equal to the inverse tan of 3 over 15, which is 11.3 degrees. So I can say that the velocity of the boat is 15.3 knots, 11.3 degrees southwest.